For every two colors of light combined to form one color of light, there is an opposite reaction where one light color splits into two light colors. Therefore, light is controlled by two factors, not one. This means that there are multiple ways to add or subtract light colors together for the same end result color. This is why there are 3 additive and 3 subtractive primary colors for black and white light to enable multiple ways of mixing light for the same end result color. One can use a 3D cube and assign light color values to all 8 points of a cube for light color values: black, white, red, green, blue, yellow, cyan, and magenta. The starting point of a 3D cube equals black, and the ending point equals white. The 6 remaining points would comprise the 3 additive primaries and the 3 subtractive primaries. 1 point connects 3 planes on a 3D cube, and 3 points of a light are mixed together to form the resulting color of the 4th point on the same plane of a 3D cube. This means 3 light colors are mixed together to result in 1 light color on 3 different planes. This correlates with the 3-dimensional directions used to determine the coordinate values of a point in space. Also, there are 3 reverse or negative dimensional directions for a total of 6 different directions used for coordinate point values of a 3D cube. 1 point consists of 3 coordinate values, x, y, and z. After 3 coordinate values are calculated for each point on a 3D cube, one can look at the values of 4 points on a plane and be able to figure unknown coordinate values of a point using the 3 coordinate values of the 3 remaining points on the same plane of a 3D cube. For every point on a plane, point coordinate values, sum of 3 coordinate values of 2 parallel points that are perpendicular to each other on the same plane, minus the value of 3 coordinate values of the diagonal point from the unknown point. The starting point of a 3D cube equals -x, -y, -z, which stands for 0 dimensions. Negative value stands for absence of dimension, or the reverse negative direction value of a dimension. Drawing a line, 1 dimension to connect the starting point to the second point equals plus x, adding the first dimension, minus y, minus z, absence of the second and third dimension. The line for adding the second dimension direction to a starting point, plus y, minus x, minus z, adding both the first and second dimension together, plus x plus y minus z, the reverse value subtracting the first and second dimensions, minus x minus y plus c would be the remaining third dimension. Subtraction, the length, height, and width from a 3D cube, minus x minus y minus z. Therefore, point 0 minus x minus y minus z equals point 1 plus x minus y minus z plus point 2 minus x plus y minus z, minus the third point that is diagonal from the starting point, also the sum of point 1 and 2. Third point values are plus x plus y minus z, so the reverse would be minus x minus y plus z. So point 0 minus x minus y minus z equals point 1 plus x minus y minus z plus point 2 minus x plus y minus z, plus reversed or negative values for point 3, negative x, negative y, plus c equals minus x minus y minus z. 6 values cancel out. Plus x minus x equals 0, plus y minus y equals 0, plus z minus z equals 0. So there are 3 coordinate direction values, negative x, negative y, negative z remaining, which would be the value of the starting point or remaining 4th point on a plane of a 3D cube. Each plane has 4 points, and each point has 3 coordinate or dimension values, so there would be a total of 12 coordinate values used for equations calculating 3 coordinate point values of a point using the other 3 points on the same plane. Also, this should go perfectly with note length values, as well as binary code values, in addition to the color values and directional coordinate values for a dimension of a point on a 3D cube for all 8 points. Here is the list of values for quarter note, half note, and whole note, along with its binary code values, color light values, and coordinate values for a 3D cube. As you can see here, so 2 to the 0th power equals 1, which equals a quarter note, which equals plus z minus y minus z. To the 1st power would be the half note, which is green, or plus y minus x minus z, or to the 1st power, which equals the half note or 2 beats. For the 4th point, to the 2nd power equals 100, or 4 equals the whole note, which is blue, or plus z minus x minus y. So a quarter note plus a half note would be 3, or the dotted half note, as seen here, red plus green, which equals yellow, which is plus x plus y minus z, or 2 to the 0th power plus 2 to the 1st power, 1 plus 2 equals 3. The quarter note plus the whole note plus x plus y minus plus x plus z minus y, is negative green, or the magenta, which would be the opposite of y, the opposite of the half note, which would be this, 6. 2 to the 0th power, 1 plus 4 is 5, plus x minus y plus z. And then 2 to the 1st power plus 2 to the 2nd power equals 110 equals 6. The half note plus the whole note is the dotted whole note, plus x, or minus x plus y plus z equals negative red, or cyan. And then if you were to add the quarter note, half note, and the whole note, plus x plus y plus z equals red plus green plus blue equals the white point, which is 0.7 right here. 2 to the 0th power plus 2 to the 1st, 2 to the 2nd. 1 plus 2 plus 4 equals 7 for the 7 beats. Quarter note, half note, and then the whole note. And then 2 to the 0th power plus 2 to the 1st power plus 2 to the 2nd power minus 2 to the 0th power minus 2 to the 1st power minus 2 to the 2nd power equals 111 minus 1 minus 10 minus 100 in binary code, which would be equal to 0. 0 equals the negative quarter note minus the half note minus the whole note, or negative x, negative y, negative z, which equals the opposite of cyan, the opposite of magenta, and the opposite of yellow, which would equal black. Or the opposite of each color. Negative cyan would be red, negative magenta would be the green, negative yellow would be the blue, for the 3 additive colors to equal black for the physics light colors.